Okay, and then in the Google Classroom, you have to go to the classwork section so you can see material for lesson 7, triangle inequality theorem. Okay, so it's in the classwork zone. So, and it will take you to something that looks like this if you do it correctly. So it says 4. All right, so we have 2 additional properties about triangles that are important to understand. One of them is a relationship just between the side lengths of triangles, and the second one is a relationship between the sides and the angles of a triangle and some patterns that occur. So once again, if you can start to think about patterns and then try to picture some things in your head, it's not that bad. All right, so first of all, if I choose to move something in this thing, let's see, oh good. So if I move something or if I do something, do you guys see how you get a correction bar up here at the top? Takes you back to the beginning. Do we all know that process? Yes. Okay, cool. So here is the question. Can you make a triangle with these 3 known side lengths? So if I have a side of 12, and a side of 7 and a side of 9, can I connect those 2 points to make a triangle? So you're going to manipulate it with your finger or your whatever, and you're going to try to get them to connect.
Yay, I made a triangle.
Was everybody able to make a triangle?
Yes.
Okay. So now in your note packet, on page 15, I think I said, right? So here we go. Note packet. I'm going to close this and get this. So, did a side of 12, 7, and 9 make a triangle?
Yes.
Yes. So we put the word yes for now. So don't worry about the next part. Now you're going to do side length of 12, 7, and 6. So I'm going to go back to my exploration. So I want to keep the 12, I want to keep the 7, but I want to change C to what number? 6. So I just use the slider. And change it to a 6. And now, can you get it to connect? So you might have to play around. They might need to lower both of them, right? Can you get them to connect? So you have to bring both points down, right? So we're getting an obtuse triangle. So did 12, 7, and 6 make a triangle? We say yes. So now we're going to try 12, 7, and 5. So I'm going to take this and try to move that C down to 5. Can I get those 2 things to meet up? Keep on going closer and closer. Do you guys think we can get them to meet up?
No, it's going to work.
Okay. But are you really making a triangle, or is it just a misdeception with because we can't see the endpoints, right? They have big blobs on them. What's true about 7 and plus 5?
They do make it.
Okay, what's true about 7 plus 5?
Oh, they equal 12.
It equals 12. So the reason why you think you're making a triangle is because this is a big yellow dot, correct? But really, the end of the line is somewhere hidden in there. So, and in fact, when they are on top of each other, they're touching like this, right? So we didn't get a triangle. So this is another no. This is now no. So do you guys think you'll be able to make a triangle if we make that side C shorter?
No.
No. Okay. Now, can everybody, now I want you to just play for a second. I want you to change the 12. I want you to change the 7. Can you make a triangle? So go ahead and play around. Make one 10, make one 5. What does the other one need to be? I'm going to make A 10. I'm going to make B 5. Oh, Ooh, it can't be 10, 5, and 5, but if I do 10, 5, and 6, ooh, does 10, 5, and 6 work? Yeah. What happens if I try to do 10, 10, and 6? Will that work?
I can't get 5, 6, and 11.
Okay, 5, 6. Oh, what's 5 plus 6?
11.
11. So if they add up to the longest side, is it going to make a triangle?
It should.
Okay, kiddo. If I have a piece of spaghetti that's 5 long and a piece of spaghetti that's 6 long and I put them end to end, how long are they?
11.
11. So can it pop up to make area underneath?
Oh, no.
There you go. Does that everybody understand that? If they add up, it doesn't work. What happens if I had that 5 and a 2? Would that be able to pop up on like a 10 or 11? No, because they don't even meet. It's a T-Rex, right? Can you guys imagine if I'm going to take B way down, B down to like 3.
Wait,
This
so-
one's down to 4. Hey, can this make a triangle? No. Do you see the T-Rex arms? I cannot make a triangle, right? It's not a sneak attack, it's a mess. So what has to be true about the 2 smaller sides? When you add them up, they have to be what?
Bigger than the.
Bigger than the third. That's exactly right. So go to your paper. They're not in order. What was in the first one? The smallest side was 7. The medium side was 9. And that is equal to what? 16. Is 16 greater than 12? So that's a yes. Do you see how that works? We do it again. Small is 6 plus 7 is equal to
6, 7.
13. Is that greater than 12?
Yes.
Yeah, so it made a triangle, right? But if I do 5 plus 7, that's only equal to 12. And that equals 12. So remember, that's the spaghetti sticks laying on top. That didn't make a triangle. And then if it's 4 plus 7, which is equal to 11, that's less than 12. And that's our T-Rex. That might be a lunch or something.
Yes.
It's all good. Okay. So there is a pattern here. And when we have patterns that can be proved in math, we call it a theorem. Yes, ma'am. Go for it. So here we go. And I used the word theorem, I think, the other day, and maybe I didn't explain that to you. We can say things are theorems if we can prove they're true. The fact that we can prove a triangle sum is always 180, that's actually a theorem. Okay, so this is called the triangle inequality theorem. If you haven't been writing stuff in your notes, this is the thing you want to write. So make sure you're with me now. We're done with the computer. You needed it just to explore. Does that make sense to everybody? Isn't it easier to explore with that computer versus trying to use spaghetti? Spaghetti is fun though. Okay, triangle inequality theorem. Theorem. A theorem is a rule you can prove. Okay, so what is the triangle inequality theorem? Okay. 3 sides form I'm going to use the symbol for triangle if the sum of any 2 sides is greater than the third. So write it down first, and then I'll explain the wording. And if you guys all read my writing?
Yeah.
Okay. So the theorem says it this way because essentially, isn't 12 plus 7 also greater than 4? Isn't 12 plus 4 also greater than 7? So the sum of any two sides has to be greater than the length of the third side. But when we want to use it as a test, oh, okay, I will let her know. Thank you. Bye. Adeline, move early dismissal. Okay, your homework is going to be in Delta Math. The video will be in the Google Classroom later today. So if you need to test if sides make a triangle, well, if the small side plus the medium side is greater than the large side, guess what? Yes! Triangle. Does that make sense? Yeah. If small plus medium is equal to or less than largest side, no triangle. Okay, so it just simplifies the method of actually practicing it. Okay, you don't have to check all 3 inequalities, you have to make one inequality. Okay, so here are some typical Regents questions. 4? What do you mean 4? It says, which numbers could represent the lengths of the sides of a triangle? What's 5 plus 9? Or wait, not length. Wait, which numbers could? Yeah, okay, what's 5 plus 9? 14, that's equal to 14, right? Boo. Okay, what's 7 plus 7? 14, that's T-Rex, right? Boo. What's 1 plus 2? 3. Less than 4. Boo. But 3 plus 6 is equal to 9, which is greater than 8. So does everybody understand I'm just putting this 9 in here so I can make sure I know what my sum is, right? So because this is true, this is, yay, I make a triangle, okay? All right, that's an actual Regents question. It can be that easy. Now, these ones are a little bit different, but not bad. It says the length of two sides of a triangle are 7 and 11. Which inequality represents all possible values for the length of the third side of the triangle? So first of all, just take a moment and look at the 4 choices. Are they the same numbers or different numbers?
The same.
All the same. So what's different from choice to choice?
Signs.
The signs. So what sign did we have to make the inequality work? Was equal okay?
No.
Equal was bad. So what's the 1? So we want the 1. So we want 7. Okay, so for example, we want 7 plus 11. What's 7 plus 11?
18.
18. So if 18 is greater than the third side, right? We're good. But that third side is an x. So we want to be less than 18, right? Does that make sense? And then notice where the 4 comes from. 4 comes from 11 minus 7 is the 4. So if we have a side of 4 and a side of 7, then the third side needs to be greater than 11. So the deal is this. We want ones that do not have the equal sign, the equal symbols to them. Does that make sense? But that's how you find those bounds. You add them and you subtract them. Okay, so that's going to help us with this one. If two sides of a triangle have lengths of 4 and 10, the third side could be. So you take the two sides. We're going to subtract them first. 10 minus 4. What's 10 minus 4?
6.
6. What's 10 plus 4?
14.
14. So we can do anything. I don't know if you guys remember the shaded inequality with the open circles, right? You can do any side length between 6 and 14, or we could do it this way. 6 is less than x is less than 14, and x is the third side. So which choice can we pick? 8. Did you guys see how 8 is the only one that's in between the lower bound and the upper bound? Okay, and so the deal, dang it, those angles are awful. But the thing is you need to hold on to that experiment you just did, right? Where if you had 2 sides that could pop up, you're good. If there were 2 amounts that added to the third side, it laid on top. And if it was 2 numbers that were less than, they couldn't connect it as a T.
Wait, how does that even work then? Because it's equal to.
So, say that again.
6 and 8 are equal to 14, so that doesn't work.
No. Okay, this is the range of sides. My sides right now are 10 and 4.
Oh, I thought there were 6.
So this tells me the bounds of the third side.
Okay, sorry, I was looking at the
No,
wrong
it's
thing.
okay. There's a lot of numbers flying around. If you're not like, and sometimes I'm bad. Sometimes I'm like, well, it's cool. You just add them and subtract them, and then there you go on. But that actually provides you the bounds, the possible values that you can use, right? Like a range of values. Okay? So yes, and then just imagine, could you imagine if it's 2, isn't that too short? Right? If it's 4, it's also too short. If it's 16, like this would be the 16, and this would be the 10, and they wouldn't meet up. Okay, so drawing little pictures can work, by the way. It's just, it's cool. The reason why mathematicians are really like awesome and nerdy is we love patterns that always work, right? Wearing black always works. It's so good. Oh. All right, moving on. Turn the page. Beep. Yes, of course. All right, so that was our first relationship. The triangle inequality theorem. It is in your dictionary, but it's hard because you wouldn't necessarily look up triangle inequality theorem, right? Nobody's going to ask you on a test, what is the triangle inequality theorem? They're going to ask you if 3 sides can make a triangle. Okay, so here we go. This second part is about a relationship, not just with the 3 sides, but angle side pairs. Like, is there a relationship there? So we're going to look at this first triangle. What kind of triangle is this, my friends? A right triangle. Is it isosceles right triangle?
No.
It's a what right triangle? Scalene right triangle. Scalene right triangle. We can write that down somewhere if it helps. So if you have 3 different angles, you have 3 different side lengths, which means you're guaranteed to be scalene. So this one over here has 3 different angles, but the largest angle is
obtuse.
Obtuse. So this is a obtuse scalene triangle. Okay. How much time do I have? I have until 1:12. We're almost done. Good. Okay, here we go. So, folks, in this pic, we're going to focus on the right triangle first. What's the largest angle? A, B, or C?
A. What? C. What? C.
C. What angle? What kind of angle is angle C? Right. It's a right angle. Now, this one. Okay, what's the longest side? Can you guys tell visually what the longest side is here? In this triangle. What side is it? Side.
It's like the B, like the diagonal one.
Okay, so friends, how many letters do we use to name a segment?
2.
2. So the segment starts at A and goes to B. So it's segment AB. Right? So if I want to, I can get crazy and put angle C, AB. Huh. They're kind of across from each other, aren't they? Okay. Can you tell visually which angle is the smallest? Is it A or is it B?
No, it's A.
So think about being a clock versus whoop, wee. A is smallest. Angle A is smallest. What is the shortest side? CB. So, can you guys see that the largest angle is across from the longest side? Do you guys agree with that? Okay. We'll do the short one on the next picture. And the smallest angle is across from the shortest side. We'll do it on the next one. So here we go. Can everybody tell that angle A is the largest? Yes. What is the longest side?
AB.
No. Longest side, CB. Segment CB or side CB. Okay. So, smallest angle. B. Right? 20 degrees. And what's the shortest side? CA. So now, this is the short side. I know I'm writing sideways. I don't know how else to do it. Short side. This is the smallest angle. Do you see that they are opposite each other, right? This smallest angle uses this side, CB, and BA, right? So angle B uses these two sides. Notice how your shortest side doesn't have a B in it, right? Okay, so this is called the side angle relationship. What? That's so silly. I know. Let me change colors here. Let's do it over here. The side angle relationship. I just want to see how I put it in my notes to make sure I do it right. Okay. And then the easiest way to remember it, I usually remember by thinking about a right triangle, because the right triangle, the longest side is always called the hypotenuse, right? Okay, so the longest side is opposite the largest angle, and then I'm just going to put the word etc. Does that make sense? We would then say the shortest side is opposite the smallest angle.
Yes.
The medium side is opposite the middle-sized angle. Okay, so how do we answer questions with this? Okay, so are we okay to go on? I want to make sure I don't do this anyway. Okay, ready? So it says in triangle ABC. Now look at these symbols and be careful. The measure of angle B is less than. The measure of angle A is less than, right? The measure of angle C. So the letter can't be used. The angle letter is not in the side letter, correct? So can we say opposite angle B is side, whoops, AC?
No. Because B is the smallest.
Okay, so it's not any of the pictures up above. So here we go. Let me do this. I'm going to draw my scalene right triangle. If angle B is the smallest, where am I going to put the B? Am I going to put the B here? Am I going to put the B here? I'm going to put the B up here. Okay. Which angle C is the largest, right? C. This is angle A. Okay. What side is opposite AC, right? That's the shortest side. So the shortest side is AC. AC is shorter than, now this is angle A. So that's going to be CB is the middle side. And then the longest side is BA. Luca, yes or no? Are you okay? Okay. So now I have a picture to help me, and then I have this pattern that this letter can't be one of those two letters, right? And now I need to just go here. Which one of these is false? Always check all four. You should have 3 trues, 1 false. Is AC greater than BC? Is AC greater than BC? No. This is false. And we drew a picture to help us, right? Is BC greater than AC? Is BC greater than AC? That should be the true one. Let's check the other 2 to confirm. Is AC less than AB? Yes. Is BC less than AB? BC less than AB. Remember, the hypotenuse is always the longest side, right? So AB has to be the longest. This one is true. So which statement was false? Very good, the first one. Now, sometimes they ask questions like that, which is straight up. They tend to use the triangle inequality theorem more as a question than this. But now this is kind of an application question of both. So let's go into it. It says in the diagram of quadrilateral navy below, the measure of angle YNA is 30. Find it, label it. Where's angle? YNA. YNA. Did everybody find it? Okay. YAN is 38. AVY is 94. And VAY is 46. Okay, so you're like, man, angle puzzle, right? Got it. And then you're like, which segment has the shortest length? What? All right. So we see, does everybody see 2 triangles? Can you find the other angles? Yeah. On your mark, get set, go. 180 degrees in a triangle, right? Add 2 numbers, subtract from 180. Add 2 numbers, subtract from 180.
I finished.
Okay. All right. This big obtuse angle up by the Y, what's that one? 122?
I got it's 112.
112. Okay, it's all right. 112. It's okay. 112. That's why we were always going to check with our calculators in high stakes situations, correct? Okay, great. Then how much was this guy?
44.
40? Because right, this is 94. You put a 94 or a 90 in your calculator.
Okay.
Okay. So they told us this angle V was 94. This one up here? Okay. So,
I put 94.
okay, good.
Together.
Okay, so here we go.
Oh, wait.
Let's look at this triangle right here.
I put in the wrong number. I chose the wrong number.
It's all good. Okay. In this triangle, which side is the shortest side?
I think it's the end.
Okay, how do we name a side, people? 2 letters.
It's probably YV or VA.
Okay, we just learned the relationship, right? Where's the smallest angle in this triangle? 30, right? Is that the smallest angle? You go across from it, so what has to be the shortest side? Fudge buckets. YA. Okay, in this triangle, listen to the question. In the big triangle, is this the shortest side of this triangle?
Oh, in the big one.
In the big one, but right, we have another triangle. So in the other triangle, it's the longest side, isn't it? So is this triangle now out of play for sides? Okay, so like our answer cannot be anything from this triangle. It can't be NY. It can't be YA.
Well, so that's the answer.
Well, I'm sorry. It can't. I'll pause on that for a second. It can't be NY and it can't be NA. Do we agree?
Okay, so
This is the shortest side of the big triangle. Let's say it's 10. But when I go to the little triangle, isn't the longest side? It's the longest side of that triangle. So doesn't this side and this side have to be shorter than this? So now we're taking out AY. This is a hard question. I'm not trying to, this is like the only question I can find that's a Regents question that they've done with this. It's okay. So this is me going to be a jerk face. I'm focused. You look gorgeous all the time. Put the stuff away. The deal is this. They mush things together on the Regents exam that you would never expect. So I can't prepare you perfectly for every question. But I can teach you all the pieces and show you some tricks of the things they put together. Are we still in like week 3, kids?
Yeah.
Am I going to put this style of question on your quiz?
No.
No. Am I going to put a sneak attack isosceles triangle?
Yes.
Am I going to put maybe a parallelogram?
Yes.
Yes. Am I going to ask you what kind of triangle a scalene is? Yes. Like, do you understand? Like the stuff that we have been repeating our butts off on, am I going to ask you? But in class, isn't it nice I'm not making you do this for homework?
Yes.
Because I'm trying to help you understand. Okay, so back to this. I love you all. Do we care about the big triangle anymore?
No.
No, go to the little triangle. What is the smallest angle in the little triangle?
YA.
This 40 is the smallest, so what's the shortest side? Short.
Virginia.
Because it's across from the smallest angle.
It's Virginia. VA.
4.
Not yet. We still have a few more hours. It's 3, Brandon. It's Virginia. We just said that.
1.
It's okay, Brandon. It's okay.
I'm gonna cry. Okay. So
But there's no crying.
I'm gonna go
We don't
backwards.
cry in math class.
I'm gonna go backwards.
Miss Ruff, what happened if we don't cry in math class?
I get to cry whenever I want.
Oh.
Are we gonna? So besides calling this class triangle class, we could call it right triangle class. I'm gonna be honest. We'll see a lot of right triangles this year. So isn't it great to know that when you do the Pythagorean theorem, pause. Everybody remember a squared plus b squared equals c squared.
Yes.
Okay. When you do the Pythagorean theorem, the longest side has to be the c. Right? A and b have to be shorter. So isn't it nice to know that the longest side should always be c? So if you do the math wrong and somehow you got the hypotenuse to be shorter than one of the sides, you've made a boo-boo. Yes. That's why these rules are great. I bet you there's going to be something like one of these on your quiz. Didn't I say like these are more typical? This is what I'm going to have you practice on your delta math. Does it make sense?
Yeah.
They think there is some side angle stuff on there, but like when I tell you like what's super important, this is super. But if I never told you about the other thing, and that was on the Regents exam, that's when I really go home and cry. You want to see me cry? Oh my gosh, when I don't teach something to the children, then they decide to test it.
That would be awful.
It feels terrible. So that's why I jump up and down and scream about triangles and angles and sides. How many letters to name a side, people?
2,
How many to name an angle?
3.
Very good. 3 or 1. Depends on the day. Okay. What does scaling mean?
None of the sides here are equal.
None of the sides are equal. If I got an isosceles, I kind of know that there's going to be a
Sneak attack.
So, if you go And there's not much time left, so I'm not going to say anything more. You have a Delta Math assignment, okay? I don't think it should be longer. I usually make them like 15 minutes long. Does that make sense? I might have thrown a couple extra things in there because we're getting closer to the end of the unit. But I still think I didn't make it super long. Can you always email me over the weekend if you have trouble? Sure. But we must start our homework before we get to class.